So for the review for this module, if you haven't worked this out yet, I strongly suggest that you go through and take the time to work out these problems first before you watch me perform them in this video. You can find examples like each of these in your 2 quizzes, in your homework quizzes, in the tasks, in the RSGs. So definitely take the time and look for them. These types of questions were in quiz 1 with what type of function they are. 7 and 8 are from the homework quiz that we talked about today. 9 and 10 are from the 3.6 homework quiz and the factoring of the cubic function. And from there you should be able to answer C and D the best you can. E might be a little tricky. 11 and 12 are what we did on today's homework quiz as well, where you are trying to find all of the zeros or the roots of the function. And then 13 and 14 is also from the homework quiz that we went over today in class and from the classwork that we did today from the 3.8 task. In addition to these questions, you will also have 2 graphs that you will have to analyze. One you will have to analyze from an equation, and one you will have to analyze from a graph, and then write the equation. So lots of things that you do need to make sure that you know, but try these before you go through and watch the video. So stop it, pause it, get that done, and then work on these. I do suggest, however, that you don't watch the whole video at one time because this is going to be a long one. Maybe try numbers 1, 2, 3, 4, 5, and 6, and then watch me go over these. Then pause it, and then maybe try 7 and 8, and then watch me go over 7 and 8. Do 9 and 10, watch me go over 9 and 10, 11 and 12, then watch me go over 11 and 12, and then 13 and 14. So break it up into chunks, pause it when you need to, write down questions on Post-it notes. I will be in my room tomorrow for help no later than 7:20. I might be there a little bit sooner, so that way you can get any last minute questions asked and answered that you might need before we take our test tomorrow. So for 1 through 5, you need to determine what type of function they are, and then you need to complete the table. I'm not going to worry about explaining how you know writtenly. I will tell you verbally how I know. First one is linear. I know this because there is a degree of 1, and degrees of 1 are linear functions. So to complete my table, my zero term will be -3, my y-intercept. And I'm going to add 4 each time because that is my slope. So 1, and then 5, and then 9, and then 13. So I added 4 every time. And when I look at the table, I see that I'm adding 4. So these are all the reasons that I know that this is linear. It grows by constant rate of change, adding 4 each time. Number 2. This is an easy one. This is a logarithmic function. I know this because there is a log in my equation. So to fill in the table for g of x, I'm going to put 1 in for x. Log base 3 of 1. Well, that must be 0 because anything to the 0 power is 1. Log base 3 of 3 is 1. Log base 3 of 9, well, 3 squared is 9. Log base 3 of 81, well, 3 to the what is 81? 3 to the 4th. So they tricked you there, thinking it might go 0, 1, 2, 3. So be very careful. And then log base 3 of 243. Well, let's see. 3 to the 4th was 81. So let's see. If I multiply by another 3, oh, I get 243. So that makes 5 3s. Moving on to number 3. This is exponential because my variable is the exponent. So 5 to the negative 1 is 1/5. 5 to the 0 is 1. 5 to the 1 is 5. 5 squared is 25. 5 cubed is 125. So you can see that in your table, this is growing by multiplying by 5. It has a constant ratio. A lot of you like to still say rate. It has a constant ratio of 5. Number 4 is quadratic. I know this because the exponent is 2. So let's plug in some values. 3 squared is 9. 4 squared is 16. 5 squared is 25. 36, and then 49. But in a table, how do I know? Here we are adding. Let's see, 9 plus what is 16? 9 plus 7. 16 plus what is 25? 9. 25 plus what is 36? 11. And then 13. So it's not linear because it doesn't have a constant rate. So then I have to look at the second difference, which is 2. So because this does have a second difference, I also know from the table that it is quadratic. So even if I didn't know from the equation, I do know from the table. And then last, because my exponent is a 3, this is cubic. So negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is positive 1. Whoa, positive 8. And then 3 cubed is 27. So now, how do I know from a table that this is cubic? This is increasing by 7. This is increasing by 1. And then 1. And then 7 again. And this is, looks like 19. So now I need to look at the second difference. I have decreasing by 6. I have 0. I have adding by 6. And I have 12. This is 6. This is 6. This is 6. It has a third difference. So from the table, I know that this is cubic because I have a third difference. So now to answer 6. 6 is determining whether the function is a polynomial. So the definition of a polynomial: positive integer exponents, cannot have negatives. We're talking just ax to the n plus bx to the n minus 1, and on and on and on and on. Because we subtract, our exponents go in order from largest to smallest. So like 5, 4, 3, 2, 1. So it'd be less than, you're taking 1 away every time. This should be relatively easy. When I look at 1, it has an exponent of 1. That is a polynomial. It's a positive whole integer exponent. Now number 2 is not polynomial. It's a logarithmic function, but you got to remember the graph. Logarithmic functions have asymptotes, which are going to keep it from constantly going to the left and to the right. So g of x is not a polynomial. H of x is exponential. Exponentials also have asymptotes, but the main reason here It says 5 to the x. X could be anything. X could be a positive, x could be a negative, and we see that in our table. Therefore, exponentials are not polynomial. 4 has an exponent of 2. 5 has an exponent of 3. Both of those are positive whole integers. Therefore, those are also polynomials. All right, now I'm going to go on to the next set of problems, 7 and 8. Find f of 3 and find p of negative 2. There are two ways that you guys can do this. You can take 3 and you can plug it in for x. And then you could use a calculator and all that work that's going to be involved with that. I don't want to do that. That's too much work. We now know synthetic division, and we can use the remainder theorem, which says I could plug in, use 3. I have 3, 5, negative 6, negative 8. There are no holes here. It goes 3, 2, 1, none. So I'm going to use synthetic division, and I'm going to find the remainder. So when I multiply, I get 9. When I add, I get 14. When I multiply, I didn't bring my calculator home today, so I'll use my phone. When I multiply 14 and 3, should have been able to do that in my head, I get 42. When I add that to negative 6, I get 36. Now when I multiply the 36 by 3, I get 108. And when I subtract 8, I get 100. So when I plug in 3, I get 100. I'm going to go through the same thing with 8. So negative 2 goes in my house. 1, negative 6, 3, negative 12. Go through the same process. Look for the remainder. Drop down your leading coefficient, 1. Multiply by negative 2. And I get negative 2. Add. I get negative 8. Multiply, I get 16. Add, I get 19. Multiply, I get negative 38. And add, I get negative 50. So when I plug in negative 2 to p of x, I get negative 50. Hopefully you guys did okay on those ones. Now let's work on 9 and 10. Use the following function to answer the questions. Y of x equals x cubed plus 64. How many roots does the function have? Well, the roots, if I look at my degree is 3, which means there will be 3 roots. So 3. Now factoring the function. To factor the function, I need to recognize that this is a difference of cubes. Sorry, a sum of cubes. So 64 is 4 cubed. So your a is x, and your b is 4. A sum of cubes is a plus b, a squared minus ab plus b squared. So everywhere I see a, I'm going to put x. Everywhere I see a b, I'm going to put 4. So this is going to be x plus 4. Now it's a squared, so x squared, minus a times b, so x times 4 is 4x. And b squared, 4 squared is 16. Now, how many real roots does this have? Well, if I take x plus 4 and I set that equal to 0, I know x equals negative 4. And if I take x squared minus 4x plus 16, and I set that equal to 0, that is not factorable. There is nothing that will multiply to 16 that will add to negative 4. So that must mean I need to use the quadratic formula. So as a reminder, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and do that. Negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 16 all over 2 times 1. All right, let's see if I can fit this all here. Okay, gonna have to try. This is 4 plus or minus. 4 squared is 16. 4 times 64, 4 times 16 is negative 64 all over 2. Well, 16 minus 64, that's going to be a negative number. So this becomes 4 plus or minus the square root of negative 48 all over 2. So those will be 2 imaginary solutions. So how many real? 1. How many complex? 2. So now we're going to find them. Well, I've already found 1. I found x equals negative 4. And I'm almost done solving the 2 imaginary. So I'm going to look at the 4 plus or minus the square root of negative 48 all over 2. So remember in class when we did this one, we have to simplify the square root of 48. So the square root of 48 is 16 times 3. And I could square root 16. So this is going to become 4 plus or minus 4i root 3 all over 2. So let's talk about where this is coming from. 4 is coming from the square root of 16. The 3 inside is from the square root of 3. Now the I comes from the negative inside the root. Now I can divide. I can simplify 2 into 4 and 2 into 4. So my other roots are 2 plus or minus 2i root 3. There are 2 of them, a plus and a minus. Now I'm going to go ahead and work. So that's it for that one. If you have questions, come and see me, but maybe this will make more sense when you see it again in number 10. So we're going to go through the same process here in 10. How many roots does the function have? If you look at your exponent, there are 3 roots. Now to factor the function, x cubed minus 5 cubed. 125 is 5 cubed, so 5 cubed. So this is a difference of cubes. A minus b, a squared plus ab plus b squared. A is x, b is 5. X minus 5, x squared plus 5x plus 25. Now, how many real roots? If you remember from the number 9, there was 1 real and 2 complex. 1 real comes from the x minus 5. So x minus 5 equals 0. X equals 5. There's my 1 real. Complex, there are 2. And that's going to come from the x squared plus 5x plus 25. There's nothing that multiplies to 25 that will add to 5. So now let's go through and use the quadratic formula. Negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 25 all over 2. So negative 5 plus or minus, this is 25 minus 100. So I get negative 5 plus or minus the square root of negative 75 over 5. Whoa, I don't know where that 5 came from. Too many 5s. So let's just look at the square root of 75. That's 25 times 3, and I can square root the 25. So I end with negative 5 plus or minus 5i. 5 is from the 25, square root of 25. I is from the negative root 3 all over 2. That I cannot simplify, so my 2 complex roots are negative 5 plus or minus, that's the 2, 5i root 3 all over 2. So all 3 solutions, 5 and then the 2 imaginary. All right, you guys, we're almost done. Number 11, find all the zeros of the following function. When you're given one factor, you're able to jump right into synthetic division. So find all zeros. There should be 3 zeros. You are given 1. Right now we know x equals 3. So 3 goes in the house. 2, -1, 13, and -6. There are no gaps, so no zeros need to be put in. Go through the synthetic division. Drop the 2. Multiply is 6. Add is 5. Multiply is 15. Add is 28. Shoot, I forgot to put the negative. I was wondering what the heck was going on there, because I knew that this was not going to work. So now I add these. Some of you probably caught that at the beginning and were waiting for me to make that mistake, but I caught it. So this gives me 2. Add, I get 6, and I get 0. So I knew that there was a mistake there because this is a factor. I was told it's a factor. Therefore, my remainder should be 0. So now I can take my 2x squared, because I have 2 x's left to find, plus 5x plus 2, and I can factor that. So I'm going to do that over here. 2x squared plus 5x plus 2 equals 0. So 2x and x. Now I need to place, when I break apart the 2, that's my c, I need to place my x so that way, or my 2, so I get 5. So I have to put 2 and 1. So 2x plus 1 equals 0. So x equals -1/2. And here x plus 2 equals 0. So x equals -2. So 3 zeros. X equals 3. X equals -1/2. And x equals -2. And then the last one, like this. So one factor is 5. So x equals -5. So -5 goes in my house. 1, 7, 7, -15. Okay, didn't miss any signs this time. So I bring down the 1, get -5, add I get 2, -10, add I get -3, add I get 15, and I get 0. And this one's going to be much easier to factor because I do not have a coefficient in front of the x squared. So I have 2 x's left to find. So 1x squared plus 2x minus 3. So I'm going to factor that. X plus 3, x minus 1. So x equals -3 and 1 when I change those signs. All right, so that wraps up solving using synthetic division. So then I can factor my remaining factor. We'll find it and factor it. All right, last two, you guys. Write the equation of the polynomial that has a leading coefficient of -3. So I'm going to start with the -3 out front. Has roots -3, so that's x plus 3. And a root of 1, so x minus 1. And a root of 4, so x minus 4. Now I'm going to multiply everything through. I'm going to start with the x minus 1, x minus 4. And then I'm going to distribute the -3 at the same time. So I'm going to have -3x minus 9. And this will be x squared minus 4x minus 1x plus 4, which will become x squared minus 5x plus 4. Now I can distribute the -3x and the -9. So -3x times the whole second parentheses is -3x cubed plus 15x squared minus 12x. Now I'm going to distribute the -9, so -9x squared plus 45x minus 36. So then I just need to combine my like terms. -3x cubed plus 6x squared plus 33x minus 36. there are multiple ways that you guys can go through the multiplication. You could distribute the negative 3 and then multiply that by x minus 1 and then multiply that by x minus 4. It's up to you. Just make sure that you distribute correctly and watch your signs. All right, last one. Number 14. Write the equation of the polynomial that has zeros at 3i, so that's x minus 3i, negative 3i, so x plus 3i, and negative 2, so x plus 2. Since they're not giving me a leading coefficient, I will assume that it is 1. I'm going to work with my conjugate pair here, the x minus 3i and x plus 3i. Because they're a conjugate pair, the middles will cancel, so I'm just going to multiply x times x, and then negative 3i times 3i, which is negative I squared. Now we need to remember I squared is negative 1. So negative 9 times negative 1, we get x squared plus 9. Now I need to multiply that by x plus 2. So I distribute my x squared and I get x cubed plus 2x squared. Now I distribute the 9 and I get 9x plus 18. And there's no like terms to combine. They are all different. So that is my final answer. I hope that this really helped. Make sure you remember to look at your quizzes, quiz 1 and quiz 2. Look at your homework quizzes. Any questions that you guys have, please make sure you come in and see me in the morning, or 6th period, you can come in and see me at lunch. And I will help you with any questions that you may have. And I will see you tomorrow.